All right, so we'll go ahead and just start here. Because we were halfway through the C version of this final exam. Remember that what we were doing was there's this bunch of weather data, and you've got date timestamps in ISO 8601 format, and then a temperature reading at that date. And then you actually have two files, and you want to find differences, various things in the first one, and then differences between the two files. We already went through a temperature report here. Remember, what we're doing with all this stuff is we're simply just using comparators and sorting to solve a lot of these problems. For example, if you want to find the minimum temperature and the maximum temperature, just sort it. One's going to be at the top, one's going to be at the bottom. For the next data report here, we want the earliest and the most recent. Right? So for that, I'm going to come back over here and cut and paste this report right here. Did I show the magic yesterday? I think I showed it in the other. I've shown block selection mode before, but did I show it yesterday here? That you can do like I want to printf and then all that stuff. I didn't want to type that 4 times, so I can go into block selection mode like that. Did I? I did. No. Okay. Then on VS Code for online for Mac, it's going to be Shift Option, right? And then what you can do is you can select a block of code, or you can select a block of code and then start typing. Hello, right? Basically, because I mean, it's not a word processor, right? Word processors would be line selection mode, but we are coders, we do more, right? And so we want block selection mode. And so that's, and you can also get that in Eclipse by going, at least on Mac, Shift, Command A, oh, nope, Shift Option A. There we go. Nope, what was it? Control Option A? Nope. There we go. Option Command A, and then you are in block selection mode here. To go back out of it, you can go back out of it with the same command. Again, Option Command A. Whatever it is on Windows, it's going to be slightly different. Okay. But in any case, let's go ahead and complete this report here. Here's the formatting, right? Let's go ahead and end that line. And for this one, I'm going to replace it with the placeholders %f and %f. All right. And again, once again, in block selection mode, right? I could do this with one line each, %s, and be done with it. In fact, I can even move over and end the line so I don't have to do all that typing, and there we go. Yay. All right. Now what we need to do, of course, is find those values. Okay? So if we're going to do this, and by the way, there is no getting out of block selection mode in VS Code, at least online. Just simply, clicking somewhere else gets you out of that block selection mode. All right, so if I want to find the earliest data set and the most recent data set, that means that I'm going to want to sort them, but not by temperature, by what? Date. And we already wrote that comparator last time, right? By date here, it's just a simple string comparator. That's why we gave you the ISO formatting, the ISO 8601 formatting. That's the only correct way of storing date-time data like that, because it stores it in a most significant value over here. If you were to write down a number, would you put the tens place over here and the millions place over here and the thousands place in the middle somewhere? No, that doesn't make any sense. So the way that we write our dates down normally doesn't make any sense either, right? But by writing them down in an 8601 formatting, right? Then you can treat it as a string and simply use string comparison to order them. Right? All right, so if I sort them by date, where's the first one? Where was the first one up here? Data set sub 0, right? Dot, what was it, date timestamp? I forget now. Date timestamp, there it is. All right, date timestamp. And then where's the last one? Data set A. And -1 dot date timestamp. Let's go ahead and make sure that that works. GCC weather. I'm not in the final. CD final. There we go. GCC weather.c and weather reports.c. What's wrong? Let's go to the top. Oh, sorry. I do, of course, need the temperature, right? Dot temperature, and then that, and then this dot temperature, and then that, right? Now, if I went back and I added a toString method or toString function, right, then I wouldn't have had to do all that manual stuff right there. But let's go ahead and compile it. Let's go ahead and test it on those small samples, input sample A and input sample B. There we go. Oh, there we go. Oh, I forgot my inline character there to make it look pretty, but that doesn't matter. What's the earliest? 2017. What's the latest? 2024. And if we look at the file, it's simple enough that we can look and see, oh, indeed, 2017 was the earliest. 2024 is indeed the most recent. Okay. So the last report here, the big one, right, because it's worth 40 points here, is we need to find inconsistencies. We need to find any data point in data set A that is missing in data set B, and we need to report any data sets A whose corresponding data in B has a temperature that's off by more than 0.001 or 001 degrees. Okay, it should look something like this. And I think in another version of this, I actually had you go back. In fact, we did on Monday, is we went back and forth, like what's in B that's missing from A, right? But this one just asks going one direction, okay? So I need this report right here. All right, let's bring that over here. Again, I'm going to use the magic to not have to type too much. Oops, Control Z. There we go. Oh. Tab over, printf, %f. There we go. And then, no, I want to click off of that. End the line. There we go. And end the line. There we go. Now, this stuff here, that's just an example. Oops. Oh, is there no comment? Okay, there we go. All right. Those are just examples. Of course, I'm going to have to find those. Now, it is identified by a date. The first data set is already been sorted by date. So let's sort the second data set just like we did in the Java example. I'm going to steal this code actually, not have to type. Right? And I'm going to sort data set B. Remember that we are keeping track of the size in a different variable there, M. And I'm going to sort it by the same date. Now, the trick that I discussed on Monday that you don't want to do is, okay, well, now that they're sorted, it should be a one-to-one correspondence. That's true if there's no missing data. What if there's a piece of missing data over here and you go down the list one by one by one? Oh, that one's missing, or this one is missing from over here, right? Now your pointers, my fingers, get out of sync. That you could figure it out and do it that way. It's going to be very, very clever code, but I don't want to have to think that hard. I want to use searching and sorting. When we get into computer science 2, there's a mantra of the course: smart data structures and dumb code are a lot better than the other way around, right? Smart data structures or smart algorithms, leveraging those, right? And not having to think about it and just having dumb code. For each element over here, search for it over there. For each element over there, search for it over there, right? Dumb code. It's just a for loop and a call to a search algorithm. That's going to be a lot better than the other way around of this really smart, clever code, right? Because that is really, really brittle and error prone. So let's outline this just like we did in Java for each data point in A, right? Find the data point in B, right? If no such data point, then report missing data. There. Otherwise, the data point does exist. So if temperatures do not match, right, their diff is greater than 0.001, then report inconsistent data, right? There we go. Else, do nothing, right? Move on. There are millions of data points in here, and I don't have that. I don't have the sample with millions of data points. We'll look at something like that here in a shortly. But there's my outline. I don't want to see 1 million instances of everything's okay, everything's okay, everything's okay. I don't want to see that a million times. Right? So for each data point in A, for int I equals 0, I is less than n, I plus plus. There we go. I need to find the data point in B. Remember that it's identified by the date timestamp. So I'm going to make a call to linear search. Well, there is no linear search, but the version in C is going to be what? Lfind, right? Or lsearch. I forget which one we covered, but let's say that it's lfind. Right? Is that going to be the correct approach? Not if I've sorted it. Remember, 1 million things over here, 1 million things over here. For each thing over here, we're not going to get around that, right? We're not going to get around a million operations over here. But if we do a million operations for each one of those, that's a million times a million. They call them 100 trillions, right? Or trillion, something. They call them trillions. Right? I'm quoting a movie there, a great old Western, Once Upon a Time in the Old West. Right? He says, that thing must be worth $1,000, thousands of dollars. And he goes, no, or hundreds of thousands of dollars. And the other guy says, nope, it's worth thousands of dollars. It comes over and says, they call them millions. Because it was a Western. So we call them trillions, right? I do not want to use an inefficient algorithm like this, especially if I've already sorted it. So let's use bsearch. bsearch is going to return a pointer. Well, if I'm searching a bunch of weather data, it's going to return a weather data pointer, right? And I'll just call it found or something like that, B, right? Because it's in B, right? bsearch. How do I call bsearch? Well, if you've sorted it like this, then that is a straight up cut and paste, except for that there's a key in front here, right? The only difference between bsearch and qsort is the key that you need to pass in. Otherwise, you're still sorting data set B. It's of size. Each one of the has a certain number of bytes, and you're using the same comparator. If I had used a different comparator here, say by temperature, right? Is that going to work? No, you're not only comparing apples to oranges, you're turning the apple inside out and comparing it to oranges, right? It's a completely different ordering, right? And it's nonsense. Right? So what's my key in this case? Well, I'm searching for the ith data point here, right? So if I have data set A sub I, that gives me the ith element. But remember that it requires a pointer. So how do I take a regular old structure and turn it into a pointer? How do I take a regular old variable and turn it into a pointer? Ampersand. All right. If no such data, how do I know if there's no such data? What will bsearch return in that case? Null. If B is equal to null, then I did not find it, in which case I need to report this missing data right here. Printf missing data, %f, %s. I'm tempted to just copy that up there. In fact, I will. End line, make it pretty. Except that it's not the first one, it is the ith one. There we go, and there we go. All right. Else if the temperatures do not match, all right, I've got two things here. I know that B is not null. If it were null, I'd be done at this point. And this is why it's an else if, right? But I know that B is not null, and therefore I can access its temperature. How do I do that? Up above, on the lines above, I was using the dot operator. B dot temperature. Is that correct? Nope. B is a pointer, and when you've got a pointer, what do you use? The arrow operator. Right? Arrow operator. Is different from, and then I do have the temperature up here of this thing. All right. Okay. So B's temperature and A's temperature, they're different. How do I write that in code? Not equals? Right? Initially, yeah. And if these were integers, I'd absolutely agree. But what if they're really, really close? 0.99999 and then 0.9999996. Those are close enough, right? no temperature station is going to be that sensitive anyway. I want to make sure that they're within, what was it again? 0.001. Or 0.001. There we go. So, not equals, but take the difference, right? And if that's greater than 0.0001, you can put that in a variable if you want to. There. Careful still, right? Put on your calc hats. Is something going to be, something could be less than that, like negative 90, right? And it will, it could be 90 degrees off, right? And it will still report it as, or not report it as, right? Why? Because the difference could be negative. How do we take care of that? Absolute value. Is that correct though? Nope. That's for integers. What is it for floating point numbers? Doubles, fabs. There we go. Yeah.
I think, is that from supposed to be there?
Oh, thank you. Right. It is different from. I just needed to erase it all. Right. There we go. All right. So if they do not match, then report printf inconsistent data. And for that, I'm going to, actually we need to report it a little bit differently. %f versus %f, %f, and then %s, and the line. So I can grab most of that stuff up there, but the second argument here will be B's temperature. There we go. Do I have to worry about A or B right here? They matched. They have the same date. Otherwise, I would not be here because of B search. All right. B here as in B in that part of the code. Else, do nothing. Good code, bad code. Bad code, that's dead code. That's I mean, you're doing nothing. Don't do that, right? Do close your for loops though. Do go back and remove your cruft, right? That was just my outline. Probably want to do that after I test it and make sure that it works though, right? All right, oops. GCC, uh-oh. Did I,
so right at 66.
66, did I forget my, yeah. 61? Ah, thank you. All right, let's try that again. Inconsistent data, missing data. We note here that the inconsistent data is 1.97 negative and 1.96. If I were to open up those sample files again, you will see, let's go back and forth. Let's unhighlight, and you see right there, going back and forth, that second one, that's the one. And then there is a missing data, 2022. We have it in A, but somebody mislabeled it as 2021. Okay. And I think I gave an output sample here, and it matches almost exactly, minus white space. Okay. I took a look at today's advent of code, and I know how to do it, but like I said, this year for some reason it is really, really hard. I've been doing them, and except for yesterday, I have not done the second part. I know how to do it. You just need to reverse the maps. Has anybody else been following along? No? Okay. All right. Well, I would not recommend doing them this year as a review for your final. I would go back to 2015 when the first few days were way easier than this. Today's required calculus, right? Today's required that we can talk about it if we get through this next exercise, but basically you had to come up with this function, and then you had to find the critical point. It doesn't mention anything about this though. Like this is, you have, yeah, it's an optimization, but it's just a simple quadratic, all right? And then you find the critical point. Be careful because calc is going to be continuous, and so you need to test both of the points on either side of the critical point, and then that gives you your answer for maximizing it. Right? It is not necessarily symmetric. So if we want to dive into calculus later, we can, but I don't want to. Right? I can show you how to implement it, but we won't actually implement it, because what I wanted to do is I wanted to go back to another, yeah, sure, save. I wanted to go back to another exercise that we looked at before. Because I want to, so you remember this zip code exercise where we were given a bunch of zip codes. I stole this from like one of the other sections, or what I thought that they were doing. And here are big zip codes. Here, let's look at a smaller file here. There are a bunch of zip codes in there. But I've got one with 1 million zip codes, and I've got one with 10 million zip codes. Right? I'm not going to open those up because I don't want to crash the editor. Right? But what I want to do is I want to go through and count up the number of times 94624 appears. Right? I want to go through and count up the number of times this one appears, and I want to produce a report like that. So all the zip codes 00000, I don't know if that's valid or not, all the way through 99999, and with a report of how many times they appear. When we originally looked at this, we looked at this like in module 7 or something when I talked about maps, right? That loading them up, there's the random maps. Basically what we did is we had, where is it? Ordered zip codes, there. We created this map here of strings. We treated the zip codes as strings because we wanted the leading zeros. And then we mapped them over to integers here. And what we did is we looked at, every time we found a zip code, we looked up the number of times we've seen it already, and we simply just added 1 right there. And then we put that back into the map. We updated it. So that means that we only had to go through the data set once. Right? What I want to do is I want to come over here into a much more, I don't want to say poor language, but I want a much more Spartan language, C, and do this. Right? So let's, where's my data here? Let's collapse this. Collapse the final. There are my zip codes. All right. So let's open up this demo here and get rid of whatever we've got in here. Get rid of all that. All right. Okay. All right. Let's start anew here. Well, here's good. Do we want some review on file I/O for C? Somebody had asked about that. Okay. So first of all, let's make a function to load up that data. And I am going to treat them as, say, do we want to treat them as integers? Yeah, let's go ahead. Let's go ahead and treat them as integers. Integers, strings. Let's treat them as strings. All right. So char star star load data. All right. So what this is going to do is this is going to returns an array of strings from the given file. Right? So load data, and I'm going to go with const char star. First week, the first week was way easier. Even last year, the first week was way easier. Lpath and int star n. Right. So what we're doing here is we're going to open up this file. We're going to read it line by line by line. Read in each one of those zip codes, and then tell you how many we read using this this function over this pass by reference variable over here. So first step, we need to open the file. Right? First step is actually error checking. Don't worry about that. We don't have time to do that. F is equal to fopen, and I want to open the file path here for reading because I'm going to be doing file input. Immediately remember to close your resources. So I'm going to go down and close it right here, but then come back up here and then start my processing. It's a good practice to follow that when you do something and you know that you need to do something else below, immediately write that code and then go back, because otherwise you'll forget. Right? My first step is count up the number of lines in the file, ... int num lines. Right? How do I count up the number of lines? Well, first of all, I need to remember a buffer. Right? And we'll just make it of size 100. Zip codes are only 5 characters, the end line character, and then the null terminator, right? We're not going to approach 100 at all, right? What's the function that I use to read one line at a time in C? Do you remember it? Or did you forget it? All right. File, get, string. Right? And you are going to read into the buffer from the file, F, And you are going to read, wait, 100, there, that's the correct order. You're going to read at most 100 minus 1, so 99 characters from this file. Why? Because it automatically puts that endline character in there for you. Remember that it also returns a pointer, char star line, which I'll call line. That's so that you can put it into a while loop. While the line is not equal to null, then read the next line. Right? So read the next line. Well, we need to do something with it, right? So if we're in here, we should say that num lines plus plus. Right? The second we break out of this loop, of course, then we'll have counted the number of lines. Why do we need to do that? Because if we're going to have a result, char star star result, I need to know how many rows it has, how many strings it has, so that I can allocate memory for each one of those. So char star star. There we go. And malloc. Size of char star. And how many of them do you want? Num lines. Okay. Oh, wait a second. Num lines plus 1? Well, more is always okay, especially if you don't use it. But people have gotten into the habit of writing plus 1, plus 1, plus 1 all over the place when dealing with strings. Because, oh yeah, right, Bertolus, null terminator, null terminator, null terminator. You drove that into my head so much that I'm doing it even for things that are not strings. This is not a string. It is a pointer to a string. Right? So no, don't do that. Right? Right? That's the number of lines. Now what you can do is for each one you can allocate exactly the number of characters that you want, which is going to be 5. They're all 5-digit zip codes. Be careful, there's an endline character there and a null terminator character though, so we'll have to deal with that. But what I'm going to do is I'm going to go into another while loop here. Okay? And keep track of that int index is equal to 0. And instead of counting up the number of lines, what I'm going to do is I'm going to set up the memory. Results of I is equal to, index is equal to a call to char star malloc of size of char times. Now it's only a zip code, so you only need 5 plus 1 for the null terminated character. You could hard code that to 6 if you wanted to, right? Because it's very, very regular data. That's why I did it with a date timestamp. I only allocated 17 because it was only exactly 16 characters plus a null terminating character. Yeah.
Do you have to rewind first?
Oh, good. All right. I was leaving that as a. There are several bugs here that we're going to have to go back. But good question. Before I start reading the next one, got to get rid of that too. Where is the file pointing to as of line 26 or 27? At the end of the file. Here's your file with 5 lines in it, right? I've counted 1, 2, 3, 4, 5. Where do I go? Well, I could close it, reopen it, which starts me back at the beginning, but I could also do that without closing it by rewinding, or rewind F, right? Why is it called rewind? Because remember, it was written in the era where everything was stored on these tape decks, right? These big giant tape reels. And so you would rewind the reel. Yeah.
Does rewind just only like rewind, I guess, to the beginning of?
Yep.
Or is it customizable? It's like any...
You can customize it, but you'd have to use FASIC. That can go back and forth, fast forward, rewind, whatever. Right? And there are you'd give it the file, and how many bytes do you want to go back? How many bytes do you want to go forward? Right? All right, so I've rewound it. I've set up the memory. Does that get me the string though? Nope. strcpy into results of index line, or line or buffer, it doesn't matter. They're the same at that point. Careful. Remember what our lines look like. I don't want that, no. Zip codes test, let's take a look at that. Seriously, you can't load 20 lines, 14 lines there, right? So what does a line look like? Well, it's got 5 numbers and an end line character. Right? I've only allocated enough space here for 5 characters and a null terminating character. Right? So one thing that I could do instead is strncpy and I'm only going to copy the first 5. Be careful, because if you do that approach, is there a null terminating character in there necessarily? Nope. So results of something equals the null terminating character. Right? What is that something? I need to set it at the end. 0, 1, 2, 3, 4, 5. There we go. So you could go 5 plus 1, or minus 1. So I'm just going to hard code it to this. Right? And then finally, after you've closed everything, return result. Okay. Let's make sure that this works before we move on, right? Iterative testing. You wrote a bunch of code, make sure it works. Write a bunch more code, make sure that it works, right? What is it? What do I call this? Load data? I'm only going to load up the small file first. Char star zips is equal to load data of, it's in the same directory here. So zip codes test.txt, right? And n, right? So I need that variable there, int n. It doesn't matter if you initialize it or not, it's going to be set in there. Actually, there, that's the other bug that I was thinking, I put in there in the back of my mind, but we didn't address. Did we ever set n? Okay, so what do we need to do? N is equal to num lines. Is that the correct way of doing it? The thing on the left-hand side is a pointer. The thing on the right-hand side is a regular old variable. So what do I do to the pointer to make it into a regular old variable so I can put a value into it? Dereference. There we go. Let's just print them out really quick for int I equals 0, I is less than n. Oops. Plus plus, printf, %s, and the line, zips sub I. There. Where am I? I need to be up 1. GCC demo. Okay. Uh-oh. Printed the first one. Ooh. Did I not null terminate something? Alright, so num lines. Poor man's debugging. Don't do this. But we're pressed for time here, so 14 lines. Okay. I rewound it. Well, that's not equal to null. Dot dot dot. Get the next line. Oh. Did I ever do anything with my index? Nope. Go on to the next index, next index, next index. All right. Let's go ahead and get rid of this debug code there. All right. Okay, still a segmentation fault. Why? 1, 2, 3, 4. All right, so mysterious segmentation fault. How do I deal with that? Recompile it with the G flag, run it through Valgrind to at least determine what line it's seg faulting on here. So line 11. That's not line 11. Segmentation fault. What happened here? So in the main, line 52. Printing it, zips. Ugh. I did set it, right? I mean, I printed it out. It was 14. Oh, sorry. These are just memory leaks. Who cares about that? There we go. It's on 52. Okay. Does anybody see the problem? Index, line, at most 5, 0, 1, 2, 3, 4, 5. Darn it. Anybody see it? I'm thinking I'm probably off by 1 here. Index starts at 0. We allocate it. Oh, duh. What is result? It is a, where did I allocate it? Right there. It's a two-dimensional array. What am I doing here? I'm treating it as a one-dimensional array. Right? The indexed one, the fifth or the sixth character, that's what I need to null terminate. There we go. All right. Sorry. I didn't expect to do this. All right, there we go. Now they're 3, 7, 1, 5. Is that the last one? Yeah, great. All right. We're all good now. All right. Now here's the actual meat. The rest of that was just potatoes. How would I actually do that? I'd go back to hack 10, pull my code, right? And simply just either cut and paste that and adapt it, or just use that function that loads up all the lines of a file. And then go through and, you know, if I wanted to treat them like integers, go A to I on each one of those. Right? But now that I've got it, that was just a review, quick review, right? Questions on that? Then let's go ahead and show you how to do this exercise that we actually wanted to do. I want to count up all the number of for each zip code, I want to report the number of times that they appear. If that's the only time it appears, great. If it appears 121 times, I want to see something like that. Okay? So, ideas. Here's where I'm going to bring in my iPad maybe. Actually, no, let's do it over here. All right. So here's my first idea. Take the first zip code and go through the rest of them looking for the number and keeping a counter for the number of times that that one appears. Okay? Then go to the second one. Go through the rest of it and count up the number of times that it appears. Okay? Just to make sure that we've got an example here that's going to break that idea, let me put 2 copies of 99493 in there. But let's go ahead and implement that. For int I equals 0, I is less than n I plus plus. Right? I want to search for the ith one. So for int j equals 0, j is less than n, j plus plus. Right? And let's keep a counter. Int count equals 0. I'm going to go through and count up the number of times that the ith one appears. So if, remember we're treating these as strings, so we need to compare zips sub I to zips sub j. Remember that j is changing for this inner for loop here. And if that matches, meaning that strcmp is going to return 0, then I can say count plus plus. Ooh, wait, too many pluses. At the end of that, I can report printf %s appears %d times. And what is it? Zips sub I and count. Right. There we go. All right, well, 99493 appeared twice, so it's good. And everything else it's small enough that everything else appears once, I'm sure. Except that I reported it twice. Okay. Suggestions on how to get around that. When I'm looking at the ith one, I need to find out, have I ever seen this before? So I could go through the entire thing again and say, oh, no, you've already seen this. Skip it, right? Okay, that's getting to be a complicated but clever code. Yeah, you could be really clever and write code that would do that successfully. Right? Other ideas. Okay, I could go through starting at I plus 1. My counter would be 1. Let's see if that works. Okay. Now, 99493 is not reported again. Right? Oh, is it? Where is it? Okay. So 99, copy that, fine, that, there it is, and where was it again? There we go, there. So I can't just look forward. I also have to say, well, have I seen this before? So you could go through all the rest of it for int seen before equals false, and for int, let me correct this back, for int j equals 0, j is, or no, we'll start at 0, and then we'll go up to, but not including I, j plus plus. And if we've ever seen it before, there we go, seen before, equals true. And then I'm going to wrap all of this into if you haven't seen it before. Okay. This is like putting duct tape upon duct tape upon duct tape. Okay idea upon okay idea upon okay idea. Right? I think that this will probably work. Let's get rid of that. G, run this again. And now we're all off by 1. That's because, oh, I needed to put my counter back to 0. Sorry. Right. There we go. Still off by 1 there. Right? Yeah, go ahead.
What if we do what we did during
Oh.
conversion and store the values that we've already seen in a table?
Okay. That'd be great if I had a data structure. In fact, that's how we did it over here in Java, remember? Not a table, but a map. Right? I'd love to do that too, but do we have... I mean, if I treated the zip codes as integers, then I would have a, 100,000 length table. The index would then be the zip code. I could do that. That sounds like overkill, though. What if there are like half of them that are never even seen, though? Those are all going to be zeros. Not only that, but I'm not going to open it up, but there are 10 million zip codes in here. Anytime you find yourself having a loop within a loop, that should be a huge red flag that this is going to be n squared. You're doing n operations here, n operations here. For something that's only 15 times 15, that's nothing. That's 225. 10 million times 10 million. Now we call them 100 trillion. That's not going to work. And not in this section, but I haven't graded this section, but in a lot of the hacks that we've seen, for whatever bizarre reason, folks have been rolling their own selection sort. Or using linear search, like they're rolling their own linear search when they should have been using binary search. That will not work on the final exam. We will be giving you big data that will take forever. Right? So, idea.
You could sort it and then zip sub I is equal to zip sub I plus 1.
Okay. If I sorted that file, what would it look like? Zip codes. Test. It would look like this. Where are the duplicates? Right next to each other. Right? So your idea of, okay, 05556. Is the next one equal to that? Nope. So it must only appear once. 18524. Is the next one equal to that? Nope. So that only appears once. Right? Now what if I get into a string where there are lots of them? For example, let's open this up and put that, come on, here, and here, and here. Right? So let's sort that again. Right? All of those repetitions. So starting at the first one, how would you go about counting them? Well, there's one. The next one is equal to it. So let's move on to the next one. Right? 2. The next one, is that equal to it? Yeah, so move on to the next one, 3. That one's equal to it, so move on to the next one, 4. Right? That one's not equal to it. So what do? Stop, report. Reset my counter to 1 here, and then continue with that same process. Okay? I like that a lot better. Right? Why? Because it only requires me to sort it. Sorting 10 million things, blink of an eye, I can guarantee. Right? Going through 10 million things once, blink of an eye, I can almost guarantee. Right? Versus 1 trillion operations taking us, I don't know, hours, days, weeks, something like that. So let's come back over here and rethink this. All right? First of all, let's sort it. Q sort. All right? I want to sort the zips. I want to, how many of them do I have? N. And how many are, in each size of char star? Be careful, right? A string is not a single character. Each thing in the array is a string, right? Okay. And then, what about my comparator here? Wait a second. That's already in the string library, right? strcmp? Nope. What does strcmp look like? Okay, yeah, whoever's online is talking Python. Yes, you can do it in Python. With maybe, yeah, with one line. Right? Python is a great language if you want to do something quick, something simple, quickly. For other stuff, if you want to do anything complicated, if you want to do it right, right, less brittle, it's not a great programming language for it. That's my opinion, though. Come on, really? You don't have the... I just want the signature. Maybe this one. There we go. Const char star. Const char star. It does return an integer. Is that a comparator? No. Right? It looks like a comparator, but it ain't. So what we're going to have to do is create our own comparator for strings. So int strcmp const void star a, const void star b. Now there is a one-liner that you could do with this, but I'm going to go through our regular pattern here. I'm going to want a const char star x, it's just a test, it's Wednesday, is equal to that.
May I have your
A,
attention, please?
oops, A,
May I have your attention, please? A tornado
B,
warning has been issued
Y.
for this area.
and then you
A
can use
tornado warning has been
strcmp
issued
on
for
x
this
and
area.
y.
Please take all appropriate safety actions at this
So
time.
that's going to be my strcmp. It is different because it's a capital C, and it is case sensitive. There are languages where functions are not case sensitive, they suck. And finding a bug is really, really difficult. So let me print them after I've Q sorted them to show you that it indeed has sorted them. Oops, I did, right? And GCC, A dot out.
May I have your attention,
What?
please?
It's not working.
A tornado warning has been issued for
Damn
this
it.
area. A tornado warning
Oh,
has
no.
been issued for this area.
This is a
Please
pointer.
take all appropriate safety actions at this time.
So the pointer needs to be changed. No, we're not going to be. Now I really wish I had done them as integers. All right. We can. With only three minutes left, I think I could do it. All right. So it's not going to be it's going to be an integer array. We only need one int here. Int star. And I'm not even going to need to copy. I don't need to allocate the space. I don't need to copy it. All I need to do is what? A to I of line. There we go. Increase the index, to close it, return it. I can do this. Int and int, and then %d, and all I have to do is change this comparator here. Int cmp, int, no, why are you typing cut and paste. And the bad thing about this is I am going to do the difference trick. Do not do that in real life. Is it correct? No, it's still not correct. So maybe I was right somehow. Oh, no, return that. Int and darn it. I still didn't get it. Is that the original? That is the original. I am printing it after I've sorted it, right? Come on, man. Int n zips int cmp %d. I'm not seeing what the problem is. Int cmp a to I line. Darn it. GCC. No, I don't know what's going on here. We're going to have to continue it next time because now we are out of time. Anybody see it? No? All right, so we'll pick it up there next time.